So in previous video we talked about the symmetric and asymmetric molecules. Now we want to say that when you have an asymmetric molecule, when you have an asymmetric molecule, for example, let's try this. Imagine you have a carbon. This is H. Here, imagine you have fluor. Here you have iodine, for example, and here bromine. So we talked before that this kind of molecule is an asymmetric molecule. It means that when you superimpose this molecule on its mirror image, they will not be similar. Here is a new definition. This kind of carbon that makes an asymmetric molecule, we call this kind of carbon, we call it chiral carbon. Chiral carbon means a carbon like I talked before. I took an example of a hand. We said that our two hands, they are mirror images of each other, and they cannot be superimposed on each other, so they are asymmetric. Chiral means handedness. So when you have a asymmetric molecule with an asymmetric carbon, you can say to this carbon a chiral carbon. So that is a definition of a chiral carbon. But we define the chiral carbon by the imagination. What is the definition, or actually what is the chemical definition of the chiral carbon? What is the chemical definition of chiral carbon? Chiral carbon is a carbon that you have four different atoms on each side of the carbon, like here that we made an example. In this molecule, you can see carbon attached to fluoride, and another side to bromide, another side to iodine, another side to hydrogen, and all of these four sides, they were different. So the carbon is a chiral carbon because of four different atoms that is attached to the carbon. That is the chemical definition of the chiral carbon. Another thing for writing in the stereochemistry, for chiral carbon, we show the chiral carbon with a star, with a symbol of star, like this. If you have a chiral carbon, we show the carbon with a symbol of star. Another thing is that why we are talking about this asymmetric or these mirror images of a molecule. What is the importance? So what is the importance of this talking? What is the importance? The importance is that when you have two mirror images, two asymmetric molecule, although they are the same molecule. For example, when you write down the mirror image of this molecule that we talked before, for example, you write the mirror image of this molecule, it will be like this. So this second one is the second one, this is the first one. These are 1 and 2 are mirror images of each other. 1 and 2 are mirror images. What is the importance that we are insisting on the mirror images? The importance is that these two molecules are different molecules. We cannot assume that the molecule 1 and 2, because of the formulation, because of the atoms in these molecules, they are the same. So we can from these conclusions, it is not true that we can say these are same molecule. So the molecule 1 and 2, although they have same atoms, same kind of atoms, same number of atoms, although they have these properties, but they are different molecules. And when they are different molecules, molecule 1 and molecule 2 have different chemical properties. So this is the importance why we insisting on the mirror images and the chirality of the carbon and these kind of asymmetric symmetric points. And here, let's say, let me talk to you about another thing, and that is what we called the molecule number 1 and molecule number 2 in comparison to each other. What we call them? We call them the 1 and 2, the molecule 1 and 2. We call them stereoisomers. Stereoisomers. So now you can find out what is the relation of these points that we were talking about and the stereochemistry. The molecule 1 and 2, the mirror images of chiral molecules, we call them stereoisomers. And later we will talk about what are the different stereoisomers and what are the name of them. So here's another point I want to talk about, and that is the name of these molecules. If you want to naming these two molecules, for example, molecule number 2, we can say, if we want to say in the alphabetic way, we can say bromo, fluoro, iodomethane. So the molecule number 2, the name of the molecule number 2 is bromofluoroiodomethane. What is the name of the molecule number 1? It is also bromofluoroiodomethane. So here you can see that the name of these two molecules, also the names are same. So how can we make differences between these two molecules? We said before that although they are same in the number and the types of atoms in the molecule, but they are two different molecules chemically. So how we make differences between these two molecules with the same name? So we were talking about the naming of these two stereoisomers and about the point in this way. We said that these two molecules are even with a similar name, bromofluoroiodomethane, and we want to separate them from each other, and we said that how we can separate these two molecules, that they are even at their name they are the same. Before that, let's point to another thing, and that is we said that these two molecules, we call them stereoisomers. So they are stereoisomers, and we said that the stereoisomers are different types. In this situation, in this example, the stereoisomers are called enantiomers. So you have two enantiomers, and they are stereoisomers. What is the kind? What is the type? Enantiomers. What are the enantiomers? The enantiomers are two same molecule, two isomers with same atoms, types of atoms, with same number of atoms, and they are different only in the way, in the position of the atoms. And here you can see the position of bromine and the bromine here, the position of fluorine and fluorine here. So you have two isomers that are similar in all the ways, but in the position of the atoms in the molecules they are different, and we call them enantiomers. So again, we call the enantiomers the isomers that are only different in the special position of the atoms in the molecule. So the only difference is the spatial positions. And here's a thing. When we say they are similar in almost all properties, we can say, for example, these two molecules they have same boiling point, they have same um, they have a same solubility, for example, and all the chemical properties even are the same. And just we insist on the spatial positions of the atoms. I'm sorry, I said before that they are similar in the chemical properties. That is not the chemical properties. They are same in the physical properties like boiling point and other things. And the only difference is the spatial position, and this spatial position make the chemical differences. And we said before, this is the importance of the splitting apart the two enantiomers. If the physical and the chemical properties were the same, so why we are splitting these molecules from others, why we are making enantiomers, stereoisomers? The importance is the chemical differences, that these chemical differences came from the spatial position difference in the spatial positions of the atoms in the molecules. So we said that they are almost similar in very properties. The only physical property that they are not the same and they act in different way is the phenomenon that we call spin polarization. What is the spin polarization? The spin polarization is that way when you impose the molecules to the light. I want to define it in a simple way, not in a complicated way. When you impose the molecules to a light line, one of the enantiomers, for example, if you call it 1 and 2, one of the enantiomers will spin, for example, like this, and the second one will spin like this. So the enantiomers have different spin polarization when you impose them to the light, and this is the difference between the enantiomers that are a kind of stereoisomers. So the conclusion of this definition is important, and I will discuss the relation of the conclusion and the naming that we were conflicting about it. So the enantiomers spin the light in a different way. For example, the enantiomer 1 spin the light to the right. You're looking at it, you see that the enantiomer number 1 spin the light to the right, and enantiomer number 2 spin the light to the left. So that is the difference between them. Here we call the enantiomer that spin the light to the right, we called it dextromer. And we call the enantiomer that spin the light to the left, we called it levomer. And you can say just the levo and the dextro. These are the importance. And now when you have the dextro enantiomer and the levo enantiomer, you can very simply differences between their names by these prefixes, like dextro, for example, dextro bromofluoroiodomethane, and you can say levo bromofluoroiodomethane, and by that you make difference between the name of each enantiomers. You can also show the dextro. You can also show the dextro with the positive and the levo with the negative. That is also correct.